If you watch long-running TV shows, you know the drill. Before a new episode starts, you get a quick montage, the classic Previously On segment. That short montage exists for a very practical reason. It saves you from having to sit down and rewatch 40 hours of television just to understand why a character is angry today. When we work with artificial intelligence assistants today, we are dealing with a coworker who misses that recap entirely. Every single time you open a new chat window, the AI wakes up with total amnesia. This means you end up doing the exact same chores over and over. You have to write out your project rules again. You drag and drop the same reference documents back into the chat. You type out long reminders about the design choices you already made together last week. You might think the solution is to just feed the AI a giant transcript of every single conversation you've ever had. But reading through hundreds of thousands of words of past chats every morning takes a massive amount of processing power, and it costs a lot of time and money. The barrier to better assistance here is not that the AI lacks intelligence. The barrier is that the AI lacks a continuous, easily readable timeline of its own daily experiences. To fix this, researchers developed a system that acts exactly like a personal TV recap editor for the AI. It's called progressive compression. The process starts during a normal workday. As your main AI assistant writes code, reads files, and solves problems, the system quietly captures a raw, messy record of those exact actions. It then hands that messy record over to a secondary, smaller AI running in the background, which researchers call the observer agent. The observer agent has one specific job. It reads the thousands of words of raw output the main AI generated and writes a clean, concise summary of what was actually achieved, often in just 10 to 15 words. As we can see in this animation, the observer agent takes those massive walls of raw code and text and squishes them down into standardized categorical bullet points. This action is the compression in progressive compression. This diagram also shows us the mathematical advantage of this method. By keeping only the task-relevant details, the observer agent achieves an 11-to-1 compression ratio. An interaction that costs nearly 4,000 words to process shrinks down to a reading cost of just over 300 words. This extraction happens continuously in the background. Every time the AI finishes a task, that complex action turns into a tiny, permanent memory bead. By constantly summarizing its own work, progressive compression turns the heavy, expensive weight of raw project data into a lightweight ledger of historical notes. Once those tiny memory beads are created, they get arranged in strict chronological order. This forms a searchable, structured timeline of the entire project's history. When you log in the next morning, the system takes the 50 most recent notes from that timeline and injects them straight into the AI's current context window, right as the session begins. A context window is the total amount of information an AI can process and keep in mind at any one moment. The reason this tiny recap works so well relies on a psychological mechanism called semantic priming. Semantic priming happens when exposure to one specific concept automatically activates related knowledge in your brain. Looking at this diagram, we can see semantic priming in action. The AI does not need to read the full 500-line code file from yesterday. Reading a tiny summary, like implemented secure login, triggers its pre-trained knowledge about security protocols, lighting up the relevant network of information. Since the AI already understands software patterns from its training data, the summary allows it to reason about the project's current state without needing to process every line of code. We are moving past the days of isolated chat sessions, where the AI forgets you the moment you close the tab. We can now maintain continuous awareness of a project over months. If you spend Tuesday working with the AI to fix a bug by adding a 200-millisecond delay to a server, the AI knows about it on Wednesday. When you ask it to build a new feature, it sees that specific delay in its morning recap, ensuring it doesn't accidentally delete your hard work. This architectural setup solves the problem of the AI's context limit. Instead of waiting for massive, expensive hardware upgrades to process millions of words at once, it uses extreme efficiency to fit weeks of context into a tiny space. The AI graduates from a reactive tool answering one-off questions into a proactive partner capable of building a complex system alongside you over time. High-level collaboration relies entirely on a shared, persistent memory of past decisions, established project rules, and earlier mistakes.
This automated diary system removes the friction of starting over every morning. Progressive compression shifts the human experience of working with AI. You no longer spend your morning managing its memory. You simply continue the project. By teaching an AI how to observe its own actions and read its own recap, we are giving it a sense of history.